Hi everybody, thanks for tuning in to this video here. We're just going to have you show you a couple of examples of converting rectangular equations into polar form. And to do that, we will take advantage of our conversion equations. We've got r squared equals x squared plus y squared. We've got its variation there, just solving for r. That's useful sometimes. Might want to keep that in your back pocket. We've also got the r sine theta equals y, and its variation there, r squared sine squared equals y squared. We can do the same thing for x variables there, r cosine theta equals x, and squaring both sides, you get r squared cosine squared equals x squared. Okay, all of those are going to come in handy at some point or another. Our examples here will just use the last two that we've got there. All right, so let's take a look at the first example. 3x squared plus 3y squared equals 75. Okay, well, those little conversion equations look like that. You see an x squared, you can replace it with r squared cosine squared. And the same with the y squared can be replaced with r squared sine squared. So let's just go ahead and do that. Just direct substitution right there, and voila, it's already in polar form right now. Now, we don't want to just stop here. We want to keep on working to isolate the r variable as much as possible. So we can see that by looking at that equation right there, we've got some common factors that we can factor out. The 3 and the r squared can be factored out. So let's go ahead and do that. 3r squared times cosine squared plus sine squared equals 75. Well, now, you who have studied trigonometric identities hopefully recognize that thing in the parentheses there. That does, in fact, equal 1. That's our fundamental Pythagorean identity there. And so we're just multiplying 3r squared times something that equals 1. So let's just simplify it. 3r squared equals 75. Nice. We can keep going, of course, dividing both sides by 3 to get r squared equals 25, and wrap it all up by taking the square root of both sides. R equals 5, and that is just a circle with a radius of 5 centered right at the origin. And that's what we started off with also. That 3x squared plus 3y squared equals 75 is the same thing. You might not recognize it. You can, let me show you one thing there. If you divided that first equation that we started off with, if you divided both sides by 3, all right, what we would get is x squared plus y squared equals 25. And you can see that from r squared equals x squared plus y squared. And that's how we would take the square root there. We don't need to take, not take the square root. But you can see that equation, x squared plus y squared equals 25, is a circle centered at the origin with a radius of 5. Okay, so they graph the same thing is the main point there. The polar form and the rectangular form would graph the exact same graph. Let's do another example here. This one, x squared minus y squared equals 1. And you might not recognize what that's going to look like if you haven't studied a lot of conic sections yet. But, you know, it's a hyperbola. It's a pretty simple hyperbola. That is neither here nor there. However, let's try to convert this into polar form. All right, so we'll use, again, our substitution equations and just drop those right in for x squared and y squared. And that gives us r squared cosine squared theta minus r squared sine squared theta equals 1. And once again, we can start to simplify that and isolate the r variable by doing some simple factoring. Just pull out the r squared. All right, so we have r squared times cosine squared minus sine squared equals 1. Well, do you recognize that little factor inside the parentheses there? Maybe you do. I hope you do. That does equal something, and if you remember your double angle identities for cosine in this case, that's cosine 2 theta. So what we've really got, folks, is r squared times cosine of 2 theta equals 1. That's already pretty simple, but let's see if we can get the r all by itself. It's not too hard, of course, just to divide both sides by cosine 2 theta. And that is somewhat acceptable form right there. We could also take the square root of both sides, although it's a little bit awkward to have the square root of a fraction. So let's take advantage of the fact that what we've got there is 1 over cosine 2 theta, or in other words, we've got the reciprocal of cosine 2 theta, and hopefully by now, my little hint right there, you may have remember that the reciprocal of cosine is secant. So we can actually write that as secant 2 theta. So we've got r squared equals secant 2 theta, or if we want to further simplify it down to just plain old r equals the square root of secant 2 theta. And that's a pretty acceptable form. Most graphing devices will handle that. Some will also handle the r squared equals secant of 2 theta. Some have a little difficulty with that, so it kind of depends on what you're going to do with the equation. But there you go, there's a couple of examples. Going from rectangular form to polar form is really a matter of direct substitution and then using whatever algebra trick you can think of or is most appropriate to isolate your r variable. Okay, thanks for watching. Go do some math and have some fun. Bye-bye.